Hey guys, so we had we had started chapter 14, right? And we went through 14.1. Any questions before we continue? No? So let me find. Okay, so where we are, right there. So now we will play with general annuities, right? We will look at amortization with general annuities. Let's do it. A debt of 30,000 with interest 975 compounded quarterly is to be repaid by equal payments at the end of each year for 7 years. So what I have present value 30,000, right? I have quarterly compounded interest rate, and I have to what end? And I have PY1, right? T is 7. Okay. Find payment using anything what you prefer, formula or calculator. Payment, I found $6,184.97, right? Yes, no? Well, how we can check ourselves? Times 7, right? So what is 43,000? Sounds realistic, right? What is the first payment? How much of the payment is interest? For the first payment, how much is the interest? Well, what we do, we can go and use amortization table, right? And find that interest 1, it is $33.69, which is what, half of it, right? Basically. Other option, what's other option? Other option we need to find P, and what is P? 10975 exponent 4, right? Minus 1. Zero 4508 35306, and we take 30,000 times P. Something's wrong. Something is wrong. What is wrong? It's wrong because it's 45%. P is 45%, and it's not realistic. That was wrong. P is wrong. Let's recalculate it. So CY over PY is 4 over 1 is 4. It means I made a booba with calculation. But why? Oh, of course. Of course. Okay, let's do it again. See what happened when you use calculator. Should be like that. Let's try. I think that's more realistic. 10% quarterly and 975 yearly should be more realistic, right? Yep, that's the one. That's when you use formulas. For the first payment, how much of the loan is repaid? So what we do? That's principal, right? That's what amount you paid minus amount you paid as the interest. So 6184.97 minus 3033.69. $3,151.28. Or you can go, that's the formula. If you go P1, P1 equals P2 equals 1. So what is your principal? Yeah, that's the one. That's the one. Same thing, right? After the first payment, how much of the loan remains to be paid? So, or what we do? We take 30,000 minus 3151.28. 26848.72. And for the P1, P2, 1. So what I have, the same thing, right? Yep. So construct amortization schedule, so we will skip on that, okay? Or somebody wants to fill the table. Yeah, if you need practice, we can do it, but I would say sometime. Who wants to build the table? Anybody here needs to do it? If no, we just keep going. We did that many times already, right? So basically, we need those kind of values for each line. We need payment, we need interest paid, principal repaid, and balance. That's what we just did for first line. Same thing will be done for every next line. And by the way, how many payments here? Huh? 7, yes. 7, 7. Okay, next. A debt of 30,000 with interest. Oh, okay. A debt by 30,000 with interest 975 compounded quarter. It's the same question, right? To be repaid by equal payments at the end of each year for 7 years. Use retrospective method. Compute the outstanding balance after 3 payments. Okay, so what we need to do here? First of all, we need to find a payment, right? So let's do it again. Compute payment. So I happen not to didn't clear the entry. That was the payment, correct? Yeah. Now they say using retrospective methods, so we need to use formulas right? And we will use the calculator, the amortization table to check our answer, okay? So what retrospective method is? We need to find two future values. First future value is a term deposit formula, and we need to have what? One. So here I have two options. Option number one, I can use I, and let's do it. What is I? 0.0975 over 4. That's 0.024375. So now, during using to compute outstanding balance after 3 payments. So 3 payments, that's T3 years, right? Yes or no? Now, since I compound quarterly, within 3 years, how many times are gonna compound? 12. So here we have to be careful. Depends what interest rate we use, quarterly or yearly, or I or P, we need to make sure we use proper exponent. So let's do it. So 40,000, $52.43. Also, we can use P, and P would be what? This, right? So I think I have it saved. Yeah, 10%, a little over. If I use P, that is what? It's yearly compounded interest rate, right? No, 3. Oh, 3 years. So what is that? And believe it or not, I have the same answer. And it's no wonder, because those two are equivalent interest rates, right? P and I equivalent interest rates. P compounded yearly, I compounded quarterly. Everybody understand that? Okay, so the second step is to calculate future value of payments we already paid, and that would be what? 6184.97. Now I need to use P here. No other options. Now exponent 3, right? Let's calculate. $20,494.49. Now what I do? I subtract like this, right? Subtract top from the bottom. So 40,052.43 minus 2494.49. I have $19,557.94. Now if I go P1 equals P2 equals what? 3. Okay, good. Because P1, that's the payment number, right? We all remember that. And I have the same number. Balance would be 19,557, and here's 95. This discrepancy 1 cent happened because we rounded payment, and calculator takes the entire value. Even
the P. What if I use I?
No, you cannot, because it's general annuity. And you calculating annuity, you have to use P. Okay. For the first calculation, I would say it's more convenient to use P, because then you don't have to think actually how many compounding periods are there. Because exponent will be the number of payments, right?
Yeah.
So it will eliminate one more chance to make an error. But as you see, both are possible, right? Both are doing the same job. Okay? So we good? Any questions? Good? Yeah, let's move forward then. So a loan of 12,000 with interest 5% compounded monthly is amortized by payments of 1,500 at the end of every 3 months. So first thing first, we need to know number of payments, right? So let's do it. I suggest that we put, okay, for now, we don't really need to know that exact n value. We will round to the full, now to even number, right? So let's do it. So what I have, compounded monthly, end of every 3 months. So 4 for PY, 12 for CY. Now 5 Y, 12,000. 300, compute n. So I found 8, 4, 8, yada, yada, yada. I don't need that tail for now. So n is what? 9. And we all understand that last payment will be adjusted, right? So it will be less than 1,500. And because here, this tail, it's almost 0.5, I estimate about $750. Because it's a half from the one, right?
Yeah.
Little less, about 750, little less. Okay. So for the first payment, how much of the payment is interest? Well, again, anything you like, you can go amortization table and calculate that is interest is 150.63, right? Then principal would be 1,349.37. Total should be 1,500, and it is, right? 37 and 63, it's $1. So it makes 1350 plus 150, it's 1,500. Okay, good. After the first payment, how much remained to be paid? So balance, what I have, 10,650.63. Good. Now construct amortization schedule. So what we do, let's find the final payment. Okay. So for that, for now, we don't know how to do it yet, right? What we will do, we find payment number, balance number 8. So let's find balance number 8. So P1, P2, what is it? 8. So I have 718.66, right? Then what I have to do, I have to find interest for 9. That's 718.66 times, and believe it or not, I need P. So 0.005 over 12. That's 0.00416 in period. So P would be what? Now CY monthly. No, monthly every 3 months. So 12 over 4 will be 3, right? Agree? No, something's wrong. Something is wrong because it's telling me 33%, and that's Uba. Yeah, that's my calculator. So that's P, right? And I put P here. I don't want to write this down every time. So 902. So payment would be what 718.66 plus 902. 727.68. That would be payment, right? Now let's check and make P1 9, P2 9. Remember that calculator overpays, right? So balance would be 772.32. It means payment would be 1,500 minus amount we overpaid, and it's the same thing.
For safety, I think always speed, not height.
We always do what?
Always speed.
I think so. When you have what? General annuity, it's better to use P because then number of compounding periods same as number of payments. So you don't have that mix. You don't think what is what. And again, nothing wrong with using I, just you need to remember that number of compounding periods must be calculated, right? So schedule, yeah, we don't calculate. Basically, we go P1, P2, 1, 2, 3, 4, 5, 6, 7, 8. And that's the last line we just found the payment, right? Interest, principal. So yeah, principal would be the balance. You understand that, right? Okay, so next. Dreamweavers financed an expansion project by agreeing to make payment of 7,000 at the end of every 3 months for the next 7 years. At the time of the purchase, money was worth 6.8% compounded annually. So using the prospective method, compute the equivalent loan value. Well, okay, so it means they want us to use formula, right? So prospective method means present value of unpaid payments, right? And it happens that all payments here are unpaid, right? Because we're looking for the cash value. So let's analyze what we have. Payment is 7,000, right? And PY is 4. Here. Money, J1, 6.8%. Okay, so annuity is general and would be what? 4 times 7, yes or no? Guys, agree? Yes? Everybody agree? Okay, so let's find then present value. It is 7,000. Oh, wow, we need P. Okay, let's find P. 68. Then CY, it's 1/4 exponent. Zero 0.01658 2931. That's P. So 1 minus 1 0.01658 2931. Exponent would be 28, right? Negative. Okay, let's find it. One 155,779.83. Alternatively, we can program calculator to calculate what? Present value, correct? So N is 28 and 6.8 IY 7,000. Payment, compute present value, and that's exactly the same number. Okay, compute the interest paid and principal repaid in 26 payments. So here we will use, if you decided to use formula, what you need to find. You need to find balance after payment number 25, correct? And then using P, calculate interest. You hear me, right? But they say using amortization for Texas instrument. So what we have, we take P1 equals P2 equals 26. Second amort. Yeah, for that you need to use calculator to find present value first. Okay, so 26. I have 300. 337. Basically, that's it. $337. Any questions, guys? What time is that? Okay. So any questions? Using the amortization worksheet with Texas yada yada, calculate the amount of interest paid in the 6th year. So 6th year, how many times a year we pay? 4, right? It means first 5 years, how many payments was paid? 20. So year number 6, we start with payment number 21, right? So we take P1 is 21. Now 6 times 4, 24. P2 is 24. So amount of interest. Let's find it. Do it. Here, guys, if you don't understand something, let me know. $2,834.64. That's combined interest all out of 4 payments. When you use formula, how would you find that interest? Guys, question. if you didn't have that calculator, how would you find that interest paid over year number 6? No, you telling me process, give me idea. If we don't have that spreadsheet on a calculator, only using formulas, how would you calculate answer for question number 3? What concept you would use there? Okay, let's analyze what is interest. Interest, it's a difference between the amount I paid and amount what was repaid, yes or no? So for that, we would need to know, balance after 5th year. We need to know balance after 6th year, right? Actually, I would rather do this. I can put minus. Yes, so that's amount of principal will be paid. Yes. Okay, so hopefully it will work this time. This one, right? No. Yeah, 14.3. Yeah, so 3 methods, right? Okay. Find n. Let's do it. Let's find n. Okay, so what we do? End of every 3 months, so quarterly. Nice and easy, right? So 10 IY, 15,000 present value, 2,500 payment, compute n. So 6, 5, 8, 1, 6, 8, 2, 2, 3. Okay? What I recommend to increase accuracy, do this. -6 equals, and then STO, let's say 1. So we remember that tail in full. Right? Now the first method. So payment, it is actually present value, right? You need to find present value. 2,500. 1 minus 10% quarterly. So 1, 0, 25. And then I go negative 0, 5, 8, 1, 6, 8, 2, 2, 3. So I use that tail as exponent. Let's calculate. $14.2606. And now, what says if payment is made at the end of payment period, add interest for 1 payment period. So payment would be this times 1 plus I, right? $14.6171. From all 3 methods, I find this the easiest one. Just what? 1 present value and you're done. Yes? Then you don't do that 1 plus I. If it's made at the beginning, it's already be here. This 1 plus I, remember? So, yes. Yeah, it's a method 3. Okay. That's the method 3. And we used that a few times already. So the second method, what second method says? Use retrospective methods, yada, 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 just after the last of equal payments. So what is the last of equal payment? Payment number 6, right? So I find future value of the loan. And again, if it's general annuity, you need to use P. Remember that, right? So now we learn principles, we learn ideas, how it works. So compound quarterly. So what we have? Yeah, it's 6. Compute the size. Okay, so $17,395.40.
It's the end, right?
Yeah. In this case, what? N is number of payments. aka number of compounding periods, because CY, PY the same. If not the same, you use P and use PY as exponent. Number of payments will be your exponent. That's why it's very useful to use P, not I. Okay? So future value of payments would be 2,500. It's 6 minus 1 over 15,969, 34. So 1 minus another. Same thing, right? And then what you do, let me use just a different color here. To save time and space. Everybody understand what we just did? Guys, everybody okay? Huh? Why I multiply by interest? Payment 6, payment 7. Payment 7 is here. You find payments right here. And that's one more interest interval, right? That's why. Okay, finally 3. Oh, let's take this color. So what I do, future value, again, we use retrospective method and we then use calculator. It's the same thing. So 15,000, we pretend that we pay 7 same payments, right? Then now future value of payments. So what just happened? You see, I paid more than I supposed to be. You see overpayment clearly, right? So that's the amount I overpaid. Now what I do, I take 2,500 minus 1461.66. So here I have discrepancy, what, 5 cents? Here I have discrepancy 5 cents. And as you see what they say, we don't multiply here by one more interval, because we already at that point of the last payment, okay? Now, let's go second amort, right? So 7, 7. And I have the same number. Oh, calculator giving me, if I go P1 equals P2 equals 7, I have 1038.29. That's overpayment. Let me double check this calculation. Maybe I made a booba somewhere. And therefore, 2,500 minus 1038.29 has to be what? Yeah, I have 14, 61, 71. Let me double check those two numbers. Maybe somewhere it is an error. Oh, of course, it's 29. Because the lovely Microsoft, what did? Decided to improve its product. But because we don't have no other options, we have to use it. So it's what here? Yep, now I have the same thing. So I just I didn't get this number right. Okay, good. So all three methods will give us the same answer. And calculate too. So which one the easiest one? The first one, right? If you use formula, the first one. All you need to do this little manipulation. Well, we can try just punch in back that number and see what happens, but I prefer, why? Because calculator remembers way more decimal places that show us on the screen. Okay, especially when you calculate, for example, take 1 divided by 3. Okay, this one doesn't show, but when you compute n, look at little star above 3 on a calculator screen. It means that we have more decimals that we see. Okay? Okay.
Can we find interest rate for the seventh payment and add it to the balance of the sixth payment by using calculator?
Well, the interest rate is the same. It's 1.025.
Interest amount paid. Numbers.
Oh, you can take 1426.06 plus, or you mean, well, then you need balance number 6 times interest and add balance plus. Yeah, you can do that. Well, you think so? If you have nothing, just formulas, you will do extra job by calculating balance number 6 instead of directly calculating outstanding payment, last payment, right? So it's possible, but it's not easy. I don't agree on that. If it was easier, we wouldn't have those three methods, though. Let's put it this way, right? Okay, guys, let's practice. On his retirement, Art received bonus of 8,000 from his employer. We remember that guy, right? And taking advantage of the existing tax legislation, he invested his money in an annuity that provides for payment of 1,200 at the end of every 3 months. If interest is 625 compounded semi-annual, determine the size of final payment. Remember, I told you at that time that the time will come when we learn how to find final payments, right? So I didn't want to do it that time, but how we would do it? Just what he just said. We would find balance before last payment times interest. That's it. The way we do amortization table, that's how we would find that payment. Okay, so what do we have? Let's do 3 methods. Practice, okay? We need n first. Go ahead. Every 6 months, semi-annually, so we have 2. Okay, and now what I remember here, I play smart and I do -7 equals, and then let's say 1. So first method, I find present value of 1200, 625 semi-annually, $693.06, and payment would be this. $714.72. Good? Guys, please, if you don't understand something, ask me questions, okay? It's very important that we're on the same page here. Okay, the second step, what? Retrospective method, right? So that's sort of prospective method for the one payment. For this piece, what we didn't pay. So future value, 8,000. Now 7. Future value of 1,200. Same thing, right? So the next step is to do this. Finally, what we have, we overpay account, right? So that's the amount we overpaid. And now 1,200 minus 485. 28. That's it. Yeah, and if you go, so beginning, try this one. Any method you want, right? Except, well, then we try all three. You choose whatever you like. Remember though that you don't have to multiply by one extra payment interval because it's annuity due. So beginning of each month. So PY12, CY12. So we play easy. So 9 IY, 7800, image 80. So what I have, N is yeah, I put what? Oops. You see that term here? Why we do that? Because it's annuity due, right? And that's what the formula is. So instead of doing that as step number 2, we already do it using annuity due formula. That's why we don't have to multiply. So that's the last payment. Yes? Okay. So here important not to forget those 1 plus I brackets, right? So so 2106, why? Sorry? Okay, let's do it again. But numbers are correct, right? Okay, let's do it again. $11,589.98. Good. No, everything's fine. Mm-hmm. So probably that's why they say it doesn't work for. Let me try something else. What just happened? Or we are. This one, right? So second amort, 53. When I do, wait, guys, you have those recordings, right? It should be recorded. Something happening today. P1, P2, 53. They say it's not gonna be used for what? For calculator, right? But I found overpayment 157.76. And now when I take 180, I have 22.24. So it works. Maybe it's not. Let's try find future value 7,800. 53. And let's just find, so third method doesn't work here. what I want to try just normal annuity, not due, see what happens. No, it doesn't work. So third method for annuity due not working. One more time, just to double check. Yeah, it doesn't work. The difference I find 158.94. So for annuity due, we use method 1 or method 2. That's it. Method 1 probably the best, right? Okay, good. Next. Payment deferred for 9 years and received at the end of each month for a fund of 10,000 deposited at 10.5 compared monthly. Determine the size of final payment. What time is that? Okay, so let's do it. We don't have much time left, so that's deferred annuity, yes or yes? Deferred for 9 years, end of each month. So payment 500 and 10,000 is here. PY 12. And what is it? J12, 10.5%. So what's first step? We find present value of payments, right? No, future value of 10,000. Nine years, monthly, 9 times 12, 108. So that amount is right here. Yes? Everybody with me? So it means then we need to find n, right? So let's use a calculator, shall we? Or you want to practice formulas? No? So it's not a I think we practiced quite a bit, right? So annuity due is not. I'm talking like Master Yoda now. Who knows who is Master Yoda? Oh, many people do. Everybody knows who's Master Yoda? Well, good. So let's find it. 12, right? So 10.5 IY 2562260, that's present value. 500 payment computed end. So 68.28834.151. So I would like for myself to check method 1, but let's do what? P1 equals P2 equals 69, right? Yes or yes? And I find that payment would be what? 500 minus 355.38. $144.62. And just for myself, I want to check that using first method. So now I need to multiply by one more interest period, right? Yep, that's the one. So we good. Yes? Any questions? Wait, guys, wait. Let me see something.
Okay.
We have 1, 2, 3, 4 questions. Let's analyze situation here. We need to plan. So we have 1, 2, 3, 4, 5, 6. So this 10 and 12 preferably review and then test, right? You want to have review before test or no?
Yeah.
Okay. So we have 1, 2, 3, 4. What? Classes. Now, let's analyze what we have here. Final payment, right? Mortgages. So next class, we'll finish this music. Okay, I think those two with final payments you can do on your own. Especially you have backup in the book, so you can check the answer, right? Now for mortgages, I would like to have a class, right? So because that's important things are there, and I want with you to discuss those things, right? So I suggest you see what I put. Read page in your book. That's basic concepts and definitions. So prepare yourself for the class. Read that fairy tale story, and then we will be more or less on the same page, right? We go over it quickly, but read it. That's just one page or something, or 2 pages. Not a big deal.
Final test completely.
Huh?
Final test completely.
Yes. So final test, of course, the main stress of the questions will be based on the last chapters, right? So chapter 14 and 15. Chapter 15, we will have bonds. Okay, so we'll finish that chapter 14 next time, and we'll start bonds.
We have another chapter.
Huh? Chapter 15, it's the last chapter. So we'll start bonds. And then, so what we will have few classes for bonds, right? And then review, bingo test, and Merry Christmas, Happy New Year. Good? Okay, guys. See you next week, right?